The Large Hadron Collider, LHC, is a mysterious and marvelous project that lies beneath Geneva. It is both a marvel of human ingenuity and a potential threat. This enormous structure, the pinnacle of scientific achievement, enables us to investigate the very fabric of our universe. It played a crucial role in the long-ago discovery of the so-called God particle, or Higgs boson. However, a shocking new development has emerged from CERN, where the well-known physicist Brian Cox made an astonishing declaration. We've noticed something strange at the collider that could have far-reaching effects that we don't yet understand. Are we getting any closer to causing our own disaster? Let's look into this scientific enigma. To fully comprehend the gravity of the situation, it is essential to comprehend the function of particle accelerators like the Large Hadron Collider. The LHC, which is run by CERN, is the world's largest and most powerful particle accelerator. It consists of a 17-mile ring of superconducting magnets, a feat of engineering prowess. Its primary function is to accelerate protons to almost the speed of light by colliding them in a manner that resembles the conditions of the universe shortly after the Big Bang. These collisions produce temperatures that are millions of times hotter than those found in the Sun's core, offering a glimpse into the extreme conditions of the early universe. CERN has established itself as one of the world's leading research institutions since its founding in 1954. It employs thousands of scientists and has 23 member nations. CERN's research is centered on the Large Hadron Collider, LHC, but it is just one part of a larger network of accelerators and experiments. Instead of a track for cars, picture a racetrack for subatomic particles. In order to replicate the conditions and energy of the early universe, the LHC aims to accelerate protons and cause them to collide. This process creates an environment of extreme temperature and pressure for the purpose of observing fundamental and rare phenomena. The design of the collider is a unique marvel, with 1,232 dipole magnets that twist the molecule radiates and 392 quadrupole magnets that center these bars before the collision. Different magnets additionally make the particles bound to impact since they pack them. All of this takes place 574 feet below the surface to shield the equipment from cosmic rays. The inside environment is colder than space, so the beams can travel around the ring in perfect condition. A sophisticated collision detector can be found in each of the four main locations around the accelerator: Atlas, CMS, ALICE, and LHCb. Thanks to these detectors, which record the collisions in great detail, scientists can now look for fundamental particles like the Higgs boson and other fundamental elements of the universe. While the Large Hadron Collider, LHC, represents a significant scientific advance, it also raises significant ethical and existential issues. Famous physicist Brian Cox, who used to work at CERN, recently brought attention to the ambitious goal of the collider, which is to recreate a miniature version of the Big Bang. This objective demonstrates the LHC's capacity for groundbreaking discoveries, such as elucidating the nature of dark matter, which constitutes a substantial portion of the universe but is largely unknown. The LHC was the result of decades of research and international collaboration, and it was a remarkable achievement. The creation of CERN was intended to promote global scientific cooperation and expand knowledge. The collider, which accelerates protons to near-light speeds and is underground near Geneva, is designed as a 17-mile ring of superconducting magnets. After that, these protons are set up to collide, emulating the conditions of the early universe with temperatures millions of times higher than the Sun's core. One of the LHC's main goals is to find the Higgs boson, also known as the God particle. This mysterious particle is essential to our comprehension of matter's fundamental structure and mass. It was discovered in 2012, which was a significant accomplishment because it confirmed previous theoretical predictions and provided opportunities for new research. Dark energy and dark matter, two enigmatic substances that account for more than 95% of the universe, are being studied by researchers at CERN in addition to the Higgs boson. Despite their significant gravitational effects, the LHC experiments are crucial for determining their true nature. However, the LHC's enormous energies have sparked concerns. Anxiety stems primarily from the possibility of forming a small black hole. Black holes are locations in space where nothing, not even light, can escape the force of gravity. Despite scientists' assurances that any black hole produced by the LHC would be minuscule and disappear almost immediately, the idea of manipulating such forces raises ethical and existential questions. A lot of risk assessments and research on the LHC's safety have been done to make sure its operations are safe. Scientists claim that there are few dangers and that the energies involved are comparable to those found in nature. However, the LHC's potential dangers have been the subject of legal and ethical concerns. In order to prevent the LHC from operating, Hawaii filed a lawsuit in 2008 due to safety concerns and the possibility of catastrophic outcomes. Despite the case's dismissal, it raised awareness of the widespread apprehension regarding massive scientific experiments. In Europe, similar legal issues reflect ongoing discussions regarding how to strike a balance between safety and scientific advancement. The LHC's ambitions and scale also raise ethical issues regarding our role as knowledge custodians. As we investigate the fundamental forces of nature, are we unintentionally unleashing forces beyond our control? These are pressing issues that require thoughtful discussion and consideration, not merely theoretical concerns. Similar to other stories about science in general, the LHC story involves moral and practical issues arising from new discoveries that alter our understanding of the world. The LHC demonstrates what can be accomplished when global scientists collaborate to answer fundamental questions, exemplifying humanity's unwavering curiosity and spirit of collaboration. However, as we investigate the complexity of the universe, it also serves as a reminder of our limited comprehension and the need for humility. As a result of advancements in computing and technology, our capacity to simulate complex systems has significantly improved over the past few years. CERN utilizes these instruments to accurately predict collision outcomes and model particle behavior. This capability contributes to risk management and ensures the collider's safety in addition to influencing the experimental design. By bringing diverse perspectives to bear on the difficulties posed by the LHC, the international nature of CERN emphasizes the significance of global collaboration in addressing both scientific and ethical issues. The LHC will continue to push the limits of particle physics with new experiments and upgrades. These advancements will enable scientists to investigate the universe's mysteries and higher energy regimes in greater depth. Regardless of whether it is investigating fundamental forces or dark matter, the Large Hadron Collider, LHC, is still at the forefront of scientific progress. Nevertheless, even as we celebrate the collider's accomplishments and the insights it provides, we must remain vigilant. The quest for knowledge is a never-ending journey in which each new discovery presents new difficulties and opens up new avenues for research.